Okay, hi everybody. We're gonna look at the homework for section 6.3 this morning. So I'll go ahead and jump right on in here. Just gonna work a couple of these. I think I was gonna do number 1 and number 5. So number 1 is a problem that has no context, which kind of makes things just simpler. And so the problem begins with sort of an overview of all the things that we talked about in class. Um, and so I think we can follow this order here, but the fact is that this is going to walk us through the answers, so we don't really have a choice about what order we do this in. So I think we'll go ahead and jump in. All right, so it says in a sample of 962, 489 successes were observed. So that's X, the number of successes, but N is the larger number of the sample size. So we can go ahead and put that in, 962. X is 489. And the number of successes is 489. Okay. The number of failures is N minus X. So I think I'll identify some of the stuff on my tablet here too. So we said that N is 962. X is 489. And that's the number of successes. Okay, so then the fails is N minus X. So 962 minus 489. So let's check that real quick. Okay, so that is 473. Okay, so both of these need to be at least 10, and of course they're well above 10. So I'm going to be okay there with my check. Okay, so let's see here. The fails, 473. Okay, and because those are both bigger than 10, the criteria are met, at least 10 successes and 10 failures each. So go with that. Should be okay so far. Okay. Now we want the sample proportion. So p hat sample proportion is X over N. So here that'll be 489 divided by 962. Do that on a calculator. Okay, so that's, and with 3 significant figures, we'll go with 0.508. Okay, now Q hat is the complement, so Q hat is 1 minus P hat. So whatever 1 minus 0.508 is. Turns out 0.492. Okay, that's good. Okay, now we got to look at the level of confidence in this problem. So up above, where? Right here, 94% confidence interval. So we'll say the level of confidence is 0.94. Okay, and then our alpha value, we can put down here, alpha is 1 minus the confidence level. So that was 1 minus 0.94. So that's just 0.06. Like that. So 0.06 there. And now we got to get this z alpha over 2. So for the z alpha over 2, you're going to table A2. Okay, so on that one, you want to go to the bottom row. There's this thing called degrees of freedom, which we'll talk more about later. Go down to the very bottom where it just says large. Those are z-scores down there. Okay, we want our alpha to be 0.06, and remember to look up under the two-tail heading. Okay. And so let's go ahead and slide. I think I've got that table right up here. Okay, so with a 0.06 alpha under two-tail, just go all the way to the bottom row on that. So it's 1.881 there. Again, you're going 0.06 two tails, bottom row, so it's 1.881. Okay, so let's put this all back. Okay, so let's put that in over here. 1.881. Check getting everything, fingers crossed. It's all good. Okay, now they're going to have us do our margin for error. So we can do this here. Here's the formula. Putting all the pieces together, z sub alpha over 2 square root p hat q hat over n. Okay, so that's the 1.881 square root. Okay, p hat, where are you? 0.508, and then times q hat 0.492. Okay, and then over n, that was 962. Okay, and we're going to do this to 3 significant digits. Oh, sorry, it looks like I've gone off screen here. There we go. Okay, so 1.881 square root fraction 0.508 times 0.492. Okay, and over 962. Okay, so everything looks good, just double checking. Yeah, okay, so enter 0.0303 is what we're going to go with. Again, we want 3 significant figures, which means we start counting at the first non-zero digit. Starting counting at that 3, we get 0303. We'll round a little more as we do some more computations, but let me put an equal there so it's clear that we're working on that last one. Okay, so let's go ahead and put the margin for error in here. I think probably worth checking that. So it's good. And now we can do the easy stuff now. So p hat minus e, these are the limits for the confidence interval. So p hat minus e. So p hat was 0.508. And then we'll do minus 0.0303. Okay, so that's 0.477. I'm going to have to round that to 0.478. 3 significant digits. And then p hat plus e, same numbers, but add. I'm going to actually steal what I did before, copy paste, and change the minus to a plus. 0.538. Okay, so those are my limits, lower and upper. Okay, so the rest of this is, we're basically out of the woods here now. So 0.478. For the lower limit, 0.538 for the upper limit. And then P, the population proportion. Remember, I'll go ahead and put that notation down. We always say that P is between these two numbers, and we're only 90, I think 90 whatever percent confident, 94% this time. So P hat minus E and p hat plus e. So we're saying the population proportion should be between 0.478, which will be 47.8%, and 0.538, which is 53.8%. Okay, fingers crossed. Looks like everything's good. Okay. And then the conclusion, we always talk about how confident we are. It's not a probability statement. Probability statements are for things that have not occurred yet, basically. And this population proportion already exists. It's either between these two numbers or not. It's not something that will happen, so or may happen. It's already true. So we're not going to talk about how probable it is. We're just going to talk about how confident we are. So let's just say we're 94% confident that the population proportion is between these two values. And that's that. 10 out of 10. Okay, so that's how you run that problem. And now we're going to go on to another one. Okay, so now we're going to look at question 5. So let me jump ahead to that. Okay, so this one says to determine an approval rate, 1,085 voters are randomly selected. I'll put down here. And of these, 507 say they approve of the president. Those are your successes. Okay. Give a 96% confidence interval. So I think I'll put up on top here that my confidence level was 0.96. And confidence interval for the president's approval rate. Okay, so we can start putting in some numbers. So N was 1085. X is 507. Okay, and so that's 507 is always the number of successes. X is the number of successes. And the failures, we'll have to do n minus x. So 1085 minus 507. Do that over here. Okay, so that's 578. Okay, and when they ask for the criteria for normality being met, those numbers have to both be bigger than 10. So successes has to be at least 10, fails has to be at least 10. Of course, I'll note that here. This is greater than or equal to 10, so a little check mark there. And the 578 also greater than or equal to 10, again, a little check mark. Okay, so yes, the criteria are met. All right, so we're all good there. And then moving on, the sample proportion here. So p hat is x over n, so x is 507 divided by 1085. We'll round to 3 significant figures here. So 507 divided by 1085. So I usually use the regular divide button if it's a simple fraction and if I want it to come in decimal, so not a fraction. So let me go ahead and hit enter there, and we'll go with 0.467. And then the complement, we need to do q hat, so we're going to do 1 minus 0.467 here. Oops. All right, so that's 0.533. So I'm going to put these in. Okay, and my level of confidence I put up here, it was 96%, right? 96% confidence interval, so 0.96. And then our alpha value, so alpha is 1 minus the confidence level, 1 minus 0.96 is the complement of 96%, which is 4%, 0.04. Okay. So we got that. And so we put that in 0.04. And just checking everything looks good. Now our z alpha over 2. So just a reminder how this works. In our little table, you go to the bottom row here. Your alpha, we're going to look up 0.04, but it has to be under 2 tails. So make sure it's 2 tails. That's a kind of a common mistake to just forget that. And that's a mistake I make pretty once in a while. So 0.04, 2 tail, that's all we need to worry about here. All right, so we are going to go on up with a 0.04, 2 tail. Let me just bring that down. So here's 0.04, 2 tails. Remember, it's under 2 tails. Bottom row. Okay, so right here is our z-score. It's 2.054. Okay, and so let's come back and put that in. .054 is what we got there. Okay, and so I'll put that in over here, and everything should be okay. So now we're ready for a margin for error. So the formula's down here. We'll just put in the numbers. 2.054 square root. So the p hat was 0.467. Q hat 0.533. Okay, over n 1085. I believe. Yeah. Okay, and let's go ahead and run that on the calculator here. Okay, so here again we like 3 significant figures, which means you start counting at the first non-zero digit. So we're going to go 0.0311. Okay, let's see if that comes out all right here. Looks great. And now we can do our limits for the confidence interval. So our p-hat value is 0.467 minus 0.0311 and there we get 0.4359, which we're going to round again 3 significant figures, 0.436 there, and then I need to add these as well for the upper limit on the confidence interval. Just a kind of a reminder, if you press the up arrow and highlight something and press enter, it does a copy paste, and you can go back and edit it now if that's helpful. So I always do that on the confidence interval. I don't like typing things twice. So here we'll say 0.498. Yeah, 498 with 3 significant figures. Okay, and so those are lower limit and upper limit. We'll say that p is between 0.436 and 0.498, and this is 96% confidence, so this should be true 96% of the time. So I'm 96% confident in it. Let me go ahead and put these numbers over here. 0.436 and 498. Should be okay. And again, we just talked about how confident we are, not that the probability is 96%, because this is already either true or false. This statement, if it's true, then obviously there's a 100% chance if it's true. If it's not true, then there's a 0% chance. Normally we like to think of probabilities for things that haven't happened. This already has happened, so it's either true or false. I'm not going to say it's 96% of the time that the presidential approval rate is between there. I'm not going to say his approval rate is between there because I don't know for sure. I'm not going to say it's a 96% probability. We just talk about how confident we are here. 96% confident. It's just a statement of how certain you are, not about whether, it's a 96% chance. Okay, so then we'll check our answer, and everything is beautiful. So that's it for this one. See you guys later.